Hello, welcome to part 4 of learning everything we can possibly learn from Apple's VisionOS documentation. We have finally got to some sample code, and we're going to look at Hello World. We're going to be looking at using windows, volumes, and immersive spaces to teach people about Earth. First, we'll download this project, and while that's going on, let's look at the overview. You can use VisionOS scene types and styles to share information in fun and compelling ways. Features like volumes and immersive spaces let you put interactive virtual objects into people's environments and put people into a virtual environment. Hello World uses these tools to teach people about the Earth, the planet we call home. The app shows how the Earth's tilt creates the seasons, how objects move as they orbit the Earth, and how Earth appear from space. Here is the app that we'll be opening. All right, it looks like that's as much as we'll see at this point. The app uses SwiftUI to define its interface, including both 2D and 3D elements to create, customize, and manage 3D models and effects. It also relies on Reality Kits, frameworks, and Reality Composer Pro. Here it looks like we have generated a 3D model of the Earth, as well as having our 2D window. Here we have several windows here to examine how the Earth tilts. And we have a cutscene here. It looks like we are looking at some sort of satellite and how it orbits the Earth. Now we're taking a look at the moon and the satellites as it circles the Earth, orbits the Earth. Okay, it looks like we have just completed our Hello World zip file, and we're going to open it soon. Let's finish up this video about the app and what we'll be seeing soon. Here's the solar system. I think we've seen this video before. Here's the moon. They're going to show us the sun soon, and then there's going to be a satellite that circles around the Earth, or it ends here. All right, looks like it ends here. Okay, so let's create an entry point into the app. Hello World constructs the scene that it displays at launch. The first scene that appears in the World app structure uses a window group. Let's go examine what this window group is taking in. Why is it called Hello World, and why is there ID modules? What are modules, and what kind of model we're pulling in, and what is window style.plane? Okay, here we have our app, Hello World app open. We are looking at the Windows app here. Looks like we're importing SwiftUI and World assets. I think that's the Reality Kits. Composer Pro assets right here. That's what we're importing. Here we have our model, which we're taking in view model, some orbit immersion styles. And let's take a look at this window group. This is our entry point to our app, the main window. Here is window group. Here's how we're using it. We have a localized string key and the ID of string and the content itself. Right? So I don't know exactly why we're using this particular string, but maybe it gives a title to this particular window app. The ID is called modules, how we'll identify this window app, and the content that we'll be showing. We'll be putting in this model into the environment for modules, this particular stack, view, and we'll be using a window style of .plane. So this is a plain window style, which does not receive a glass background in VisionOS. Use this style if you want more control over how glass is used in your window. All right, this is our first window group. Let's open it up and see what's happening. while it's opening up. Like other platforms, for example, macOS and iOS, VisionOS displays a window group as a familiar looking window. In VisionOS, people can resize and move windows around the share space. Even if your app offers a sophisticated 3D experience, a window is a great starting point for any app because it eases people into the experience. It is also a good place to provide instructions or controls. Tip: this particular window group uses plain window style to maintain control over the glass background effect that VisionOS would otherwise automatically add. Okay, let's take a look at this app. Let's look at that first window before we move on. Where is this simulator? Oh, we're still loading. Okay. And we are in. We are looking at Hello World. This is great. Let me move this down a little bit so we can see this a little better. Okay. Just that much. Okay, perfect. So this is our home window. This is modules. This module looks like it holds 3 different separate views. Down here, these are probably of the same particular type with different data points in them to populate that. Here is Hello World. I don't know exactly why. Window group. As you can see, it's not transparent. It doesn't have a glassy background. It has nice graphics that we can see here. We can resize this to be a little bigger for us. Give me a moment. Like that, like so. Very cool. All right, so let's view this head on. Very interesting stuff. I can't imagine seeing this in the VR headset. Sorry, VisionOS Pro headsets, and that would be amazing. Okay, let's look at the next piece of documentation and move appropriately. Present different modules using a navigation stack. After you watch a brief introductory animation that shows the text Hello World typing in, the module view that defines the primary scene content presents options to explore different aspects of the world. This view contains a table of contents at the roots of a navigation stack. Here we have navigation stack, a path. This is a binding to a model.navigation path. We have a table of contents, navigation destination, the module itself for a module itself, and we'll take a module and module detail, put that module in, and create a navigation title module.eyebrow. A VisionOS navigation stack has the same behavior that it has in other platforms. When it first appears, the stack displays its root view. When someone chooses an embedded navigation link, the stack draws a new view and displays a back button in the toolbar. When someone taps the back button, the stack restores the previous view. The trailing closure of the navigation destination for and destination view modifier in the code above displays a view when someone activates a link based on the module input that comes from the corresponding link initializer, navigation link, value, module, and the link label. Yeah, let's take a look at this more deeply. This is very interesting. So the navigation destination closure view modifier in the code above displays a view when someone activates a link based on the module input, corresponding link initializer navigation link. Interesting. Let's take a look at that code and see what that means. But before we do that, the possible module value that comes from custom module enumerations are the following: global, orbit, and solar. Okay, let's dig into this code and let's see if what we understand about it. So we're going to go straight to modules. All right. I think we can click this preview. As we wait for the preview to load, let's take a look at that navigation stack. This is a navigation stack. It looks like a view that displays a root view, enabling you to present additional views over the root view. Use a navigation stack to present a stack of views over a root view. People can add views on top of the stack by clicking or tapping a navigation link. Remove views using built-in platform appropriate controls like back button and swipe gestures. The stack always displays the most recent added view that hasn't been removed and does not allow the root view to be removed. To create navigation links, associate a view with a data type by adding navigation destination for destination modifier inside the stack view hierarchy. Wait, sorry, we were reading. Sorry. Then initialize navigation link that presents an instance of the same kind of data. The following stack displays a park detail view for navigation links that present data type park. List park navigation stack. Here is a park navigation link. This is the destination where we will take the user to the park details view. And navigation link is a park's name, and view value is going to be park. Okay, that's pretty cool. All right. Okay, so we have a navigation stack. What does path do? Creates a navigation stack with homogeneous navigation state that you can control a binding to a navigation state for the stack. The view to display when the navigation stack is empty. Okay, so why do we need this path? What does the path do for us? Well, I think it tells us the information about where we're at, maybe. I mean, we can always remove the path and see what happens and add the path back in. So let's take a look at this. So we have a days in life of planet Earth. Pretty cool, right? So let's zoom out a little bit to make sure we see all of this. Perfect. Okay, let's make sure that happens for us. Let's see what's gonna happen if we remove this path. As you can see, we can run this navigation stack without the path. And I don't know exactly what we'll lose, but we'll have to find out. Let's lose it. All right, let it reload. Don't know what's gonna happen. Just gonna find out. Let's click it. Nothing changed. Everything works the same. Exactly the same. That's a little annoying. I don't know the difference. Let me pause the video and go look for that difference. Okay, so we're digging around again into more information about the navigation stack. This is a view that holds navigation links of that nature. And we're looking into this particular path and this particular binding. Let's take a look at what this exactly does for us. By default, a navigation stack manages states to keep track of the views on the stack. However, your code can share control of the state by initializing a stack with a binding to a collection of data values that you create. The stack adds items to the collection as it adds views to the stack and removes items when it removes views. For example, you can create a state property to manage the navigation for the park details view. Add states create a array of park views, and then we initialize the states as an empty array, indicating a stack with no views, providing a binding to the state property using a $sign prefix when you create a stack using the init path at root initializer. Here we have the $sign presented parks, and we have this list and the same old destination, the list of parks, and the destination where we'll be taken to. Like before, when someone taps or clicks navigation link for a park, the stack displays the park detail view using the associated park data. However, now the stack also puts the park data into the presented park array. Your code can observe this array to read the current stack state. It can also modify the array to change the views on the stack. For example, you can create a method that configures the stack with a specific set of parks. Here we have show parks and set presented parks to Yosemite and Sequoia. The show park method replaces the stack displays with a view that shows details for Sequoia, and the last item in the new presented parks array navigates back from the view, removes Sequoia from the array, which reviews a view that shows details for Yosemite. Use a path to support deep link state rasterization or other programmatic navigation. Navigate to a different view type. To create a stack that can present more than one kind of view, you can add navigation destination for and destination modifiers inside the stack view hierarchy, with each modifier presenting a different data type. The stack matches navigation links with navigation destinations based on the respective data type. To create a path for programmatic navigation that contains more than one kind of data, you can use a navigation path instance. Oh, that's interesting. I believe this is navigation path instance. Let's see. Let's go look into the model a little bit then. Let's take a look at that. All right. Here we have our view model. It's observable. That's nice. Navigation path. It's a module type. So it's of the same type. We have module.swift, and here are what our modules look like. Here are enums, IDs, names, eyebrows, headings, abstracts, overviews, call to actions, and fun facts. Very nice. Oh, right. So here's our model. We want to save the paths. We don't necessarily need to do it. The effect, however, is that we are able to remove things from the stack, and it will bring us back to a particular place in our views, which is interesting. All right, look, we have a table of contents. Let's take a look at that struct as well as we move in. Here is our table of contents. We grab our model. We have a binding to our model, and we have an image of a sun sliver, opacity, title finish. Let's see, title text. Discover a new way to look at the world. Where is our information background? Okay, it looks like it's the background that's going on here. I believe that this is our list. This is similar to our navigation link, or well, yes, our list of parks, of navigation links. So this is their table of contents. I'm sure we can find navigation link in here somewhere. Navigation stack. No, what's going on? Did I mistake something? Because I mean, here's the destination, and there needs to be a link, right? I mean, the link is how we view what we're looking at. Let me look into that. Okay, it just took a little bit of digging. So here we go. We go into a table of contents. We scroll down to our H stack that we see, and we see that we're looking at a module card. And once we head into the module card, we'll see our navigation link with our modules, the module eyebrow, and the heading, and the whole description for the link, and the frame, how it looks. And we have this card with the glass background, and perfect. So with that, we have our navigation links. We then have our destination afterwards, our modifier, navigation destination that we need. and for each module, and we do a module detail view for each module with a navigation title module eyebrow, and that's going to be .get inside the module. Here's the module detail with all the information for what we should toggle and all this information here. Perfect. So with that, we have gone through a little bit of the navigation stack code, how it works, the modifier, what it opens, how we click through, and we understand navigation stacks now. Perfect. And we will now go on to talk about display an interactive globe in a new scene. All right, let's take a look at this next topic here. Display an interactive globe in a new scene. The globe module opens with a few facts about the Earth in the main window next to a decorative flat image that supports the content. To help people understand even more, the module includes a button titled View Globe and opens a 3D interactive globe in a new window. To be able to open multiple scene types, Hello World includes UI application scene manifest key in its information property list file. The value for this key is a dictionary that includes UI application support multiple scene key with a value of true. All right, let's go in there and take a look. Here we have our plist file over here. I believe it is somewhere general. Let's see. Plist. Is this over here? Build settings, build options, dependencies, signing capabilities, resource tags. Aha, info. This is where our plist is at. And application scene manifests enable multiple windows. Great. And we have, let's see, what else were we looking for? We're looking for, I think that's it. Well, here we have declare a volumetric window for the globe. With the key in place, the app makes use of a second window group in its app declaration. This new window group uses the global view as its content. Window, globe, and we look at the module.global.name. That's going to be our ID. And we're going to have globe in this window group, .environment with the model. This window style is going to be volumetric, and we're going to have a default size of 0.6, 0.6, and 0.6 in meters. This window group creates a window that has an arbitrary depth, great for displaying a 3D model in a bound region that behaves like a transparent box. Because Hello World uses the volumetric window style scene modifier, people can move this box around the shared space like any other window. The content remains fixed inside. The default size is going to be width, height, and depth, and in a particular measurement, and modifier specifies the size of window in meters, including depth dimension. Globe view contains 3D content, but it's just a SwiftUI view. It contains two elements in a Z stack, a subview that draws a model of the Earth, and another that provides a control panel that people can use to configure the model's appearance. Let's take a look at that. Here we have modules. We're going to go into globe. How we look at that is we have a navigation destination. We look at navigation details. Let's go into that. Where we have our modules. We particularly have the globe toggle here. The toggle, it does a call to action, a view model open, and it does a show globe. That opens the window of the globe.name, which opens this particular window, which we see here in the Windows app, as this is the same name as module globe.name. We open the globe. Let's take a look at this. We have a Z stack, as is said earlier, with an earth that gives has some animations, some globe Earth. That probably pulls it from our world assets. And we have some accessibility actions that we can take a look at here. Then we have some drag rotation, moving around, alignment guides, so on and so forth, some controls, and on change, rotation, and show globe, false and true. And so that's what we're looking at. Some toggles here and there. Show sun, show poles, show rotation, is rotating, make sure it rotates, is tilt, pick, things of that nature. We can go back into our navigation stack here. Let's take a look at this inside our app then. Where are we? Is it, where's the app? Here it is. Hello world, planet Earth, view the globe. Of course, this takes a little bit of time. And here it is. Here's the globe that we can see. Here is the tilt poles right here. We can show that. Here it rotates. We add that rotating view to it. That's very cool. We have some tilt March equinox. So at June, interesting. So September, and December. Does it change its tilt? I think it's tilting towards the sun. Yeah. That's where the sun is going to be shining from. That's because it's circling around the Earth at a tilt. All right. Less about the Earth, more about the code. Okay. And we have to open and dismiss the global window. The globe module presents a view globe button that people can tap to display the volumetric window or dismiss the window depending on the current state. Hello World achieves this behavior by creating a toggle with the button style and embeds it in a custom global toggle view. In the global toggle view, we have a view with some environments, open and close, dismiss. Here's a bindable with the model. And then we're going to do a toggle with the module globe call to action is on show globe, on change, show globe. We turn that to, if it's not showing globe, then we dismiss this particular window and we toggle the toggle style is not button. So when someone taps the toggle, the is show globe state changes, and on the on change modifier, it calls the open or close dismiss window and dismiss the globe. The view gets action from this environment and uses an identifier to match the window identifier. I think we saw this a little earlier. Right, let's go take a look at that. So this is the is globe on disappear on change. This is how we change these. Let's go take a look at that toggle in our code. So here's our details. Let's go into that. And there is the global toggle. As you can see, this toggle changes and updates our open and close windows on the change of is globe, snow globe. And this toggle, let's see where we use this toggle. So show colors. I don't think that works properly. Do a find. And we do search here. And we do enter and we see that we have the toggle in the details. That's where it's seen. And we have this toggle to open and close it. I'm sure it's supposed to be somewhere else too, but it looks like that's the only place it's shown. That is interesting. Well, I don't see a dismiss button here. Do you? No, I don't. So let's close the globe and it disappears. Oh, I see. Nice. Okay, with that, let's go on to the next section. Display objects that orbit the Earth. You use Windows in VisionOS the same way you do in other platforms, but Windows in VisionOS provides a small amount of depth you can use to create a 3D effect, like elements that appear in front of other elements. Hello World takes advantage of this step to present small models in line with 2D content. The app second module objects in orbit provides information about orbits that go around the Earth, like the moon and artificial satellites. To give a sense of what these objects look like, the module displays 3D models of these items directly inside the window. Hello World loads these models from the asset bundle using a model 3D structure inside a custom item view. The view scales and positions the model to fit into the available space and applies optional orientation adjustments. That is very cool that we have item view, which scales this model that we're looking at. Okay, here's the item view. This is the item that we're pulling in and the orientation. We're going to set it to 0. We're going to take the model and put the item with .name, more modifier, take the model resizable, size to fit, and we're going to give it a rotational 3D effect, rotation 3D, and rulers angles, right, from the 0 degree. Give it a frame with a depth, model depth, and offset by negative model depth divided by 2. So it comes forward a little bit because the negative axis is towards you and the positive axis is away from you. Then we have a placeholder for progress view that's closer to you as well, the model depth information. Okay, that's very cool. The app uses item view once for each model, places each in an overlay that only becomes visible based on the current selection. For example, the following overlay displays the satellite model with a small amount of tilt in the X and Z axis overlay, and the item view of the satellite's orientation that we've chosen. And that's a 0.15 of the x-axis and the 0.15 z-axis tilt. So it's kind of like a slight tilt of an opacity of 1 or 0, depending on the selection. Okay, that is very cool. Then let's see, there's more here before we go and look at the code. The VStack that contains the models also contains a picker that people can use to select a model to view. Here's a picker with the satellite, then the selection, and we have items, all the classes, item.name. So we have all the items in the segmented picker style. When you add 3D effects to a 2D window, keep this guidance in mind. Do not overdo it. These kinds of effects add interest, but unintentionally obscure important controls or information as people view the windows from different directions. Ensure that elements don't exceed the available depth. Exceeding depth can cause elements to clip, accounts for any position or orientation changes that might occur after initial placement. Avoid model intersection with the backing glass. Again, accounts for potential movements after initial placement. Okay. All right, let's take a look. Remember, what we're looking at is the satellite view. Let's go into modules. Let's go to modules details. We're going to hit up the orbit. Orbit's going to call this window, open module, orbit. Let's go to the app and pull that up. Here's the module, orbit model. And here's the view model. We should have the satellites. We have orbit Earth, moon configuration. That is interesting. That is outside of my idea of where this is supposed to go, because I was thinking that we would get information that we need. Maybe it's in the card. I am pretty sure it should be in the details. Here's the toggle. I think I deviated from that perspective right there. Okay. Well, looks like all the orbit stuff is here. Orbit modules here. Here's the item view. That's interesting. Let's see why I wasn't able to find it. That is really odd. Let's enter that there. Module detail. That's our detailed view. Yeah, I think that's where we missed it. Okay, that's all good. So where we missed it was the extension. Yes, that's where we missed it. Okay, that's very cool. Um, so keep scrolling, remember. And so let's go back into this and let's look at the item view. And we have satellites orientation as seen. Let's take a look at the item views. Item view is down here inside of this orbit module class and takes in the item class. That's interesting. It's an enum type item. That's so cool, this type of code. Okay, we have these cases, case iterable, it's string itself. That's how we pull the item from the model. And here's the picker. Here's the model. Here's a depth. Here we're placing it. Let's take a look. Here's the picker. Here are the objects with a little slight tilt that we can choose. That is very cool. And if we turn it to the side, you can see that it's floating in front of the window just a little bit. Can't select anything from this angle. That is so cool though. Imagine just looking at this in a VR headset and moving around. Maybe not moving around. This is not what we want to do. We don't want to be viewing objects by moving our own head. Of course, you can't get up that high either. All right, very great. Here, I think we have gone over this code properly, and let's keep moving. Let's keep moving because this is all about SwiftUI. This is not about Reality Kit or Reality Composer Pro, where we create these objects. We're just placing them at this point, and how do we place them? Okay, let's keep moving. Show Earth's relationship to its satellites in an immersive space. People can visualize how satellites move around the Earth because the app orbit module displays the Earth, the moon, and a communication satellite together as a single system. People can move the system anywhere in their environment and resize it using standard gestures. They can also move themselves around the system to get another perspective. To learn about designing with gestures in VisionOS, read gestures. To create this visualization, the app displays the orbit view, which contains a single reality view that models the entire system in an immersive space scene with a mixed immersion style. Here's immersive space. We take in the module, we click orbit, and we put in the model with immersion style mixed. I think this should be an app, I believe. This is where it should be, and we're showing it. As you can see, here's our immersive space. Here's our module. This opens up orbit, and this is our view, 3D view. As you can see here with our view model, here's our Earth. It has all these configurations and placements. All right, that's exciting. Let's take a look at that in code then. View orbits. So we generate this model here. We have the moon circling around the Earth. It's so cool. We can move these around. I think we can make this bigger. Oh, no, I just got closer to it. I I don't have that ability at this point to make it bigger. Just have zoom in and zoom out capabilities. Pan, tilt, interact. Maybe, no. Oh, there we go. Here we go. So we get too close here. Can we do a drag? Oh, here we go. There we go. It zooms in and zooms out, as you can see. And as you zoom in, where's the moon? The moon gets bigger too. I think there's a limit to how big it can grow. Exciting. And now we have the Earth and the moon in the living room. And we can observe how a satellite moves around the Earth. and how it circles the Earth in a spiral formation. Looks like it's a slight tilt. We have the sun blasting down on Africa, South Africa. Well, it's from one angle. Looks like it's the days going by here from that one angle. It's interesting how the sun and the moon are aligned here. And I think let's get back to the code. All right. So, and as with any secondary scene in VisionOS app, this scene depends on having UI applications support multiple scenes. Key in the information property list file, this app also opens and closes the space using a toggle view that resembles the one used for globe. Here's orbit toggle. We open and close it in the same way, but we're opening and closing the immersive space. We can see this toggle here. And it just works in a similar way by moving the Earth out of the way and clicking this orbit button, it disappears. All right, let's take a look at the code. It's our orbit toggle. This is open and dismiss space. We can also see that this button is going to be only available on the module details. Very nicely done. There are a few key differences from the version that appears in this section. Open and dismiss globe. Orbit toggle uses open immersive space and dismiss orbit immersive space from the environment rather than window equivalent. Dismiss action in this case doesn't require an identifier, but because people can only open one space at a time, even across apps, the open and dismiss action for space operation asynchronous, so they appear in a task. All right, let's get to the meat of this. We're gonna look into full immersion now. View the solar system from space using full immersion. The app final module gives people a sense of Earth's place in the solar system. Like other modules, this one includes information and a decorative image next to a button that leads to another visualization, in this case, so people can experience Earth from space. When a person taps the button, the app takes over the entire display and shows stars in all directions. The Earth appears directly in front, the moon to the right, and the sun to the left. The main window also shows a small control panel that people can use to exit the fully immersive experience. People can exit full immersion by pressing the device's digital crown, but it's typically useful when you provide a built-in mechanism to maintain control of the experience within your app. The app uses another immersive space scene for this module, but here with a full immersion style that turns off the pass-through video. As you can see here, immersion style is now set to solar immersion style, which is thoughtful. The scene depends on UI application scene multiple scenes, key to support other secondary scenes, and is activated by a solar system toggle that's similar to the one that we've seen in other scenes. Okay, let's take a look at this code here before we move on. Here's the app, here's the selection. Why are we selecting this particular selection? Sets that allow styles for immersive space, selection of binding that effective to the effective style used by the space, the list of style that the immersive space allows. Interesting. Okay, so this is what's allowed, this is what was selected. All right. Here's the code and the toggle where we dismiss and open the space. This is also a task. And we have a label, big label here, that is shown in the toggle itself, exits. And we have a system image, arrow down right, arrow up left, and text module call to action. Interesting. So let's take a look at where this code lives in the world, and maybe it lives in two places, I believe. It does. It lives in module details, and it also lives in the solar control. So it lives in two places, unlike the other ones. So we can exit the space. Well, let's take a look at that since we're here. Can we recenter? Great, that's a nice recenter button. All right, here we're gonna open the immersive space. Okay, I understand the risk. All right, and we are here. This is our nice little window. This is our space. Let's pan around a little bit. Here's the moon. Here's the sun. I think there's a satellite going through. Let's zoom back in. And we can click these buttons to go through. Oh, we need to interact with it. And we have left and right arrows that presents us tilt and sunlight and information about the Earth. We have that exit button as well. So I think we're coming to a close here. This control appears in the main window to operate a way to begin the full immersive experience, and separately in the control panel as a way to exit the experience, because the app uses this control as two distinctive buttons rather than as a toggle in one location. It composes of a button with behavior that changes depends on the app states rather than as a toggle with button style. To reuse the main window for the solar system control, Hello World places both the network navigation stack and the control in the Z stack, then sets the opacity to ensure that only one appears at a time. I see, that's a nice way of doing it. And here's the exit the solar system, the image, and depending if it's showing solar, we do this, or do the call to action. All right, very cool. With this, we have reached the end of the article for Hello World, and we'll be going into the next article in the next part, as this video has gone pretty long already. And we'll be looking into presenting windows and spaces, and let's learn more about the SwiftUI components of VisionOS.